Good morning. Transformations of trigonometric functions. Let us start the discussion with the transformation stretch. In our normal function y equal f of x, normally two types of stretches are possible. Isn't it? What are the two types of stretch? One is vertical stretch vertically. The other one is stretch horizontally. Okay, so when you stretch it vertically, that means stretch towards y-axis. Stretch towards y-axis stands for the result is affected to the whole y. That means result is affected to the whole f of x. Yes. So if you stretch a function with a stretch factor a, for example a, if you stretch a function with stretch factor a, then the stretched function will be y is equal to a f of x. Y is equal to a f of x. A function y equals f of x is stretched with a stretch factor a in a vertical direction, then the new function formed will be y is equal to a f of x. Okay, when it comes to the matter of trigonometry, there also it's very simple. For example, we have function y equal sin x, or y equals cos x, or y equals tan x. Let it be any function, any trigonometric function. Suppose we stretch this function with a stretch factor a vertically, then the new function formed will be y equals a sin x. So this is known as a vertical stretch towards y-axis. Stretch towards y-axis. That is known as a vertical stretch, and that is formed by y is equal to a sin x, or y is equal to a cos x, or y is equal to a tan x. Now let's see what change happens when you stretch a function vertically. First, let us make the graph of y is equal to sin x. Okay, so we are going to stretch the graph of y is equal to sin x, the function y is equal to sin x. So first let's make the graph of y is equal to sin x. Okay, sin 0 is 0. So let me make the ordered pairs first. Okay, these are the ordered pairs formed, like sin 0 0, sin 90 1, sin 180 degree 0, again sin 270 degree minus 1, and sin 360 degree 0. So let's mark these points on the graph. We get the corresponding graph of sin x in a simple way. So sin 0 0, sin 90 1, sin 180 0, sin 270 minus 1, sin 360 again 0. So when you join this graph, when you join these points, we form a smooth curve. We know that is the corresponding graph of y is equal to sin x. Now let's stretch it vertically as y is equal to 2 sin x. Let's see what happens and what change happens to y is equal to 2 sin x. So I have made the graph of y is equal to 2 sin x here. I haven't shown you how to prepare this graph. I'll show you in a simple method, that one. Okay, so when you look at this graph, you see when you start with 0, as the stretch factor is 2, it reaches till 2, then again it comes to 0, minus 2 and 0. So when you look at this graph, the new graph formed, here the change happens only in amplitude. Where the change happens? Only in amplitude. See here, the amplitude was 1. Now the amplitude changed to 2. So what changes here? Only the amplitude changes. And there is no change in the period. Period remains same. Okay, you can see the period of this graph is 360 degree. Yes, which makes one complete graph. The period is 360 degree. It remains 360 degree for our new transformed graph also. Stretched graph also has same period. But what happens to the amplitude? The amplitude changes. Okay, so let's see how to do this one in a simple way. Okay, and when you see an ordered pair, when you find an ordered pair, it has first term as degrees, angle, and second term is its value, isn't it? Remember, the first term is period. It affects period. If there is any change in period, it affects the first term. That means horizontal stretch or horizontal translation. Anything related to the horizontal transformation affects the first term. 0, 90, 180, 270, 360. And anything related to the vertical transformation affects the second term. Okay, so the vertical changes are affected on the y coordinate and the horizontal changes affects on x coordinate. Okay, so here the work is very simple. As it does not affect the horizontal transformation and it affects on the vertical transformation. So horizontal transformation, horizontal coordinates remain the same. And for vertical, what happens? We are multiplying 2 times sine. So multiply the second term with 2. So second term is 0 multiplied by 2 is again 0. 90 degree changes to 1 times 2 is 2. 180, 0 remains 0. 270 minus 1 multiplied by 2 is minus 2 and 360 0. As it is multiplication, as it is a stretch, when it comes translation, instead of multiplication we need to be added. We discuss that later in the class. So you see, we get 0 0. I marked 0 0. 90 degree 2, 90 degree 2. 180 degree 0, 270 degree minus 2, 360 degree 0, and frame a new graph. We get the graph of this. Okay, and when you look at this function, the original function is y is equal to sine x. It changed to y is equal to sine ax. So you can find the change happens to x. The previous question, change happens to sine x. The total function was changed. But in this question, only x is transformed to ax. So only the x coordinate getting changed. That means horizontal change. And this change is called the horizontal stretch. Horizontal stretch. Okay, as we learned in functions, if y is equal to f of x can be stretched horizontally as y is equal to f of ax with a stretch factor 1 over a. Y is equal to f of x can be stretched horizontally to y is equal to f of ax with a stretch factor 1 by a. Similarly, y is equal to sin x can be stretched to y is equal to sine ax horizontally with a stretch factor 1 by a. We can do it with example. It's very simple. So let us consider one example. Y is equal to sine x transform to y is equal to sine 2x. So when you consider this question, you can find there is a stretch for this function with a stretch factor 1 by 2. So stretch factor is 1 by 2 as it is a horizontal stretch. So I made the graph of y is equal to sine x here. Now when you consider this question, in the previous question it was y is equal to 2 sine x. The stretch was happened to the overall function that was vertical stretch, and in vertical stretch the amplitude got affected. The change happened to the amplitude and the period remains same. But in horizontal stretch, amplitude remain same. What changes? Period changes. So in horizontal stretch, period changes but amplitude remains same. So when you are seeing this ordered pairs, amplitude remains same. That means it remains 0. It remains 1. Here it remains 0. So what change you can find here? The period gets changed. That means first term gets changed. And what change happens to the first term? Based on scale factor. As scale factor is 1 by 2, the period is reduced to 180 degree, because you know the period of a sine function is 360 degree. Because you can see from 0 to 360 it makes one complete graph. Yes, so period of a sine function is 360 degree. As the scale factor is 1 by 2, take the half of 360 degree. So that the period changed to 180 degree or pi radian. Okay, so this change happens to every angle. So 0 degree change to remains as 0 degree only. 90 degree change to 45 degree. 90 into half. 180 change to 90 degree. 270 change to half of 270 is 135 degree. 360 change to 180 degree. Okay, so that change happens to every first coordinate, every angle. Okay, so when you mark it 0 0, 45 1, 45 comes here, 45 1, 90 0, 135, 135 comes here, minus 1, and 180 0. So our graph changes to in this position. See, our graph is stretched, isn't it? Okay, and when you continue this graph, next point will be 1. Next comes here. Next comes here. Isn't it? So graph changes in such a way. So here what are the changes you need to identify in stretch? So there are two types of stretch. One is horizontal stretch and the other is vertical stretch. So in horizontal stretch, amplitude remains same and the change happens to the period, that means first coordinate. Y is equal to f of x changed to y is equal to f of ax with a stretch factor 1 by a, and in case of vertical stretch, period remains same and the amplitude changes. as the height changes. Y equals f of x become y equals a f of x with a stretch factor a. Okay, so for this function, in horizontal function, change happens to the first coordinate and y coordinate remain same. And in vertical stretch, change happens to the second coordinate, y coordinate, and the first coordinate remains same. Okay, so these are the main points we need to think about stretch. Have used only sine function. In another class we discuss about cos function. Now let's discuss about translation. Once we know stretch and translation, we can do the problems related to combined transformation of trigonometric functions. Translation. There are two kinds of translation. Not only two kinds, we have the third kind also, which is a combination of horizontal and vertical. So first, let's discuss about these two. The first one is horizontal translation and the second one is vertical translation. Okay. In horizontal translation, a point is translated from one place to another place horizontally. Just do the translation. No change in shape or the side. Okay. In horizontal translation, if a function y is equal to f of x is translated to y is equal to f of x plus a, then it has a translation vector minus a 0. Okay, you can find here where the translation happens. X changes to x plus a, x changes to x plus a with a translation vector minus a 0. That means there is no change for y coordinate. X coordinate changes to minus a. Similarly, in case of vertical translation, a point is translated vertically in the direction of y-axis. That means y changes. So y is equal to f of x is a function translated vertically as y is equal to a f of x. Sorry, a plus f of x. It is not a f of x. It is a plus f of x or f of x plus a. What is a f of x? A f of x is stretch. It is f of x plus a with a translation factor or translation vector 0a. Okay, and when it comes to the topic of trigonometry, y equals sin x is a trigonometric function is translated to y is equal to sin x plus a. Sin x plus a with a translation vector minus a 0. And vertical y is equal to sin x is translated to y is equal to a plus sin x. Make sure this a you are adding pre-addition we have to do. Okay, with a translation vector 0a. So here also you can find where the change happens. Here the change happens for x coordinate, that's for angle. And in vertical the change happens for y coordinate. Okay, that means the value. So let us make a translation of y is equal to sin x plus 90 degree. Sin x plus 90 degree. But when you check this question, you can find x is added with 90 degree. That means there is a horizontal translation. X gets changed with a translation vector minus 90 0. Minus 90 0. And the trick to find this one is very simple. See, x coordinate gets changed and y coordinate remains 0. So what you have to do is change x coordinate. Our x coordinate is 0. Just do minus 90 with that. So we get minus 90 degree 0. The next point, 90 minus 90 is 0 degree and y coordinate remains same. Next, 180 degree minus 0 is 90 degree, y coordinate remains same. 270 minus 90 is 180, y coordinate remains minus 1. 360 minus 90 is 270, y coordinate remain 0. So the change happens only for x coordinates. Okay, and there won't be any change in period or amplitude. Period or amplitude remains same in translation for horizontal and vertical translation. There would be change in period and amplitude for stretch. Okay, let's mark this point. Minus 90, 0 is this point. 0, 1, 90, 0, 180 minus 1, 270, 0. So our graph would look like this. You can see this graph was translated to this side. That's it. Okay, but when you are making this graph, make sure the domain provided, like you may get the question as x would be from 0 degree to 360 degree. So when it starts from 0 degree to 360 degree, you are not allowed to draw this part because it is below 0 degree. Okay, so in such case you have to start the graph from 0 degree and you cannot stop the graph here because it is up to 360 degree. So you have to continue the graph till here. Okay, so it is also a very simple work, and in the next class we will do how to handle with the complicated problems like if y is equal to a plus or a sine bx plus c. If you get a question like this, how to find the value of a, b, c, etc. It's not only with sine, we do with cos, tan, etc. Okay, thank you.